Shashank Dutta and welcome to my project Road Accidents Analysis. According to National Transportation Department, in 2021 there were around 6.1 million road accidents in the US, out of which 42,000 people died. So looking at these numbers, we can say that it's very important to understand what road accidents are, how to analyze them. So what are the key factors involved in road accidents? So through my dashboard, I want to analyze these key factors in road accidents, and this analysis can be used to create preventive measures. So here my dashboard consists of different charts. So I have the zoomable choropleth map, I have the bar chart, and I have all these different charts, so each serve a different purpose. So and these are the insights I have gathered. So my data set, my raw data set is a huge data with 2.8 million rows. So I have only selected the 2017 data set and did some pre-processing, and since the census data I have is also 2017, I wanted to keep similar timelines data. So the total number of accidents in 2017 was 147,000, and the other insights we can explore through the dashboard. Yeah, so this is my dashboard and this my backend server it is running. So this is the dashboard, so I will explain each component or each chart in detail. So if you see the first one, this is the severity thing. So the road accidents are classified into three types: low severity accidents, medium severity, and high severity. So once, let's say I want to only look for data that has low severity, I just click on low severity, and as you can see, all the other charts are changed. If I want to look only for high, I will only look for high, and this all is for if you want to look for all the accidents irrespective of their severity. So every chart is linked to every other chart, so everything changes when you change one, or when the user selects one component. Yeah, so and the next one is the choropleth map. So this is a zoomable choropleth map. The person can zoom this has across all the US county level map. So you can zoom. If the user wants to select, he can select, and respectively all the other graphs changes. If he wants to see what is the, so this is in Minnesota, so you can also select multiple. You can deselect if you want to, and all the other graphs changes. Yeah, so this is the scale that I'm using for coloring. So as of now, it's taking the total number of accidents in that county as a variable, as a metric, and this is how the scaling looks like. So these are like has more number of accidents compared to the other. So let's the other map is the stacker bar chart. So in the stacker bar chart, we can see that you can hover over a single stack area. So this is the one I'm showing right now is on Wednesday from 4 p.m. to 7 p.m. So in this way, you can see the distribution of accidents across different weekdays and weekends. Also, you can see in a particular day or in a particular time slot what is the distribution. So right now for Friday at from 4 p.m. to 7 p.m. the number of accidents are 8,458. So you can click, if you want to, you can click multiple if you want to, and subsequently all other graphs change. You can also deselect. Yeah, and the next is a tree map. So this basically gives you the tree map for employment. So let's say the user selects some county, so he or she will see the total population. He can see what is the distribution of employed, what is the distribution of unemployed. He can also see he total population which has professional jobs, population which are doing office jobs. So in this way you can correlate the number of accidents to the employment and get some insights. And the next one is accidents by hours. So this is a time series area chart. So this shows you for a particular day, or for a particular day, how is the distribution of accidents every hour. So you can see, so at 8 a.m. so it was so at 8 a.m. there were 10,000 accidents. So you can easily see what are the peak times where there are more accidents, and yeah, you can make well informed decisions based on this visualization. So user can select multiple times, and all the other subsequently changes. You can also deselect. And the next one is the POI radial bar chart. So this bar chart includes different point of interest locations. So let's say there were 33,000 accidents that occurred near a junction. So user can see how many accidents occurred in every junction, what in every location, what location has most accidents. He can also click, and all the other graphs changes. He can click multiple, he can deselect. Yeah, he can deselect, and this particular small bar shows the percentage of accidents that happen in non POI locations. So out of the total number of accidents, so 61% of accidents happen at a non POI location, and the other percentage was POI location, and this value says the same. The next plot is the weather PCP parallel coordinates plot. So this plot can be used to relate weather to the number of accidents. Let's say I want to brush for temperature between 50 to 100. So you will see the graph only with that. The data will be filtered, and you will see the data where accidents occur during this particular time. You can do this particular temperature. You can do multiple brushings. Also, if you want to, you can also change the axis, reorder them in whatever way you want to visualize your parallel coordinates plot. Yeah, that's all. These are the main features. These are the main charts. So if the user wants to reset all of them, he can simply select this button and everything will be reset. Yeah, so coming to the interaction, so everything is, so I have made sure that all the charts are connected. So whenever you click on one chart, all the other charts changes. So this is you can do brushing, linking, and everything else changes. So in that way, I made sure that every chart is connected to the other chart in one way or the other way. Yeah, so coming to insights, so there are a lot of insights, since the user can select any graph, and since there are a lot of interactions, the user can easily see a higher level of data. Like, so let's say he wants to look for something like Suffolk County, and he wants to look only on Tuesday at 4 p.m. to 7 p.m. How is the distribution of accidents per every hour. He can do that. He can also select only crossing. So there's a high level of detail the user can attain. So because of that, there are a lot of insights that the user can gather. So some of the insights I came across are I would like to show those. So let's say if you take this choropleth zoomable map, so this is basically our Suffolk County. So here it is in red color. That means that this county has more accidents and is not that safe. But if you so this color schema takes into account only the absolute number of accidents. So let's say some user wants to have let's say we want to see how are the number of accidents with respect to population. We want to include our population also as a factor. You can simply click on this show per capita, and it shows you the number of accidents per capita. So it basically maps accidents and population, and based on that, so this is a new metric that is created, and using this metric I, I have done the color map now. So now you can see that the Suffolk color turn into green. So in that way, so only looking at absolute number of accidents uh, might be misleading. You have to also take into account the population of that particular county to get better results. And the another insight I would like to say is, if you look at this uh, stack bar chart, so you can see that during weekdays there are more number of accidents compared to weekends, and also in weekdays if you see the distribution is similar, and the majority of accidents occur from 6 a.m. to 7 p.m., and after 7 p.m. you can see that there is very the number of accidents decrease. So this is same for all the weekdays, but if you take weekends, so weekends is the opposite is true. So if you take weekends for weekends, you can see after 11 p.m. there are a lot of accidents compared to others. So for weekdays, so the opposite is the case for weekends. Yeah. And also you can confirm the same thing using the time series area chart. Let's say I want to look at these two peaks, 8 a.m. to 8 a.m. and 5 p.m. You can see that the weekdays have significantly more number of accidents compared to weekends during 8 a.m. and 5 p.m. And let's say I'm selecting something like 11 p.m. or midnight, something like that. So if I select something like 11 p.m. and after, so you can see that there are more accidents during weekends compared to weekdays. Yeah. So the other thing I would like to show you is, let's say I'm only interested in looking at severity level low severe accidents. You can see for low severe accidents, weekdays have more total number of accidents compared to weekends. So for weekends it's significantly less compared to weekdays. So, and let's say, and the peak, if you look at the peaks are during early morning 7 a.m. to 8 a.m. and during 5 p.m. So but if you look at high severe accidents, they so it is evenly distributed. The number of accidents are evenly distributed compared to the low severity accidents, where there are significantly more accidents during weekdays compared to weekends. And also the time series, if you look at the time series, you can see it is evenly distributed too. There is not a single peak. So what we can infer from this is, during weekdays, people, there are a lot of vehicles on road. People will commute to schools, people commute to workplaces. So during that time, what we can say is, so during that time there can be small accidents, like small collisions that can happen, and because of that collisions, the low severity accidents increases. Maybe those small collisions are mostly during when people are at a junction. So these are the places, a traffic signal or crossing, these are the places where there is a high chance of traffic congestion, and then these small collisions might happen, which contribute to the low severity. And these typically happen during when people are going to their offices during 8 a.m. and when people are going to their offices during 8 a.m. or when people are returning back to home. So during that times, during these places, these small collisions can happen during weekdays. But on weekends, that's not the case, because the number of vehicles are low compared to weekday, and also there is not much rush in traffic. So that's another thing I wanted to say. And yeah, so yeah, this one. So these are the top three, if you take the whole US data into account. So these are the top three places, point of interest locations, where there are significantly more accidents compared to other locations. Also, a lot of accidents occurred at a non POI locations. So if so the other one is, let's say I'm taking humidity. Let's say I'm taking humidity. So if you take low values of humidity, you can see that there is a peak at 5 a.m. or in the evenings. But let's say the humidity increases. So the humidity increases, and then the peak changes from the peak changes as soon as the humidity increases, the peak changes from evening to early morning. So this what we can infer from this is, during if there is high humidity during early morning, so there's a lot of fog that is formed, and due to that fog, when the sun is rising, the driver behavior might change, and the driver, it would be difficult for a driver to drive in that particular lighting condition when there is high humidity and there is fog and there is there is sun rise. So during that time, it is difficult, and because of that, maybe the number of accidents are more during the during this early time, early morning time. So yeah, and this one. So if let's say I'm selecting uh, yeah, so let's say I'm selecting temperature. Let's say I'm selecting the temperature, and this is how the graph is. Let's say I'm at let's say if the temperature is high, then we can see that the peak is during the evening, and let's say the temperature is going down, you can see that the peak changes. So similar to humidity, if the temperature is going down, then the peak changes in the morning. So early mornings, when it is too cold early mornings, then there is high chance of accidents. And if the temperature is high, then in the evenings, people get tired or irritated due to high temperatures, and then in the evenings there can be high chance of accidents. Yeah, I think that's all I wanted to show. These are some visualizations and some insights I could gather from my data. Thanks for watching.